Welcome everyone. So today we are trying to understand how to solve this kind of a indices problem where we have 3 into x raised to x is equals to 3 raised to x plus 10. So now see, in this kind of a situation, LHS we are not able to do much in this case. So we'll keep the LHS as it is as of now. Then your RHS looks like a raised to m plus n, which can be written as a raised to m into a raised to n. Okay. Now using the same logic, I can write this as nothing but what, 3 raised to x into 3 raised to 10. Okay. Now please understand, in mathematics we always follow the rule of keeping the variables on one side and the numbers on another side, meaning I will divide both sides by 3. Okay. At the same time, I will also divide both sides by 3 raised to x. So now what happens is this 3 and 3 is cancelling. This 3x and 3x is cancelling. What are we left with is just x upon 3, and both of them are still raised to x. And here you have 3 raised to 10 upon 3. Okay. Now remember, in indices, whenever you have a raised to m upon b raised to m, both of them with the same index, you can write this as nothing but what, a upon b the whole raised to m. Using the same logic, what I will do is I can write x upon 3 the whole raised to x. Similarly, a upon a raised to m upon a raised to n, if you had, then what we would do is a raised to m minus n, sorry, my bad. So here, if you look in your RHS, you have 3 raised to 10, and here you have 3 raised to nothing, means 3 raised to 1. Okay. So here, like I said, I can put it in my everything in my numerator by nothing but just subtracting the indices like I did over here. So I have now, the question is changing to what, 3 raised to 9 in my RHS. Okay. Now please understand, whenever you have, let's me write this down one more time, x upon 3 the whole raised to x is equal to 3 raised to 9. This is where I have come to my question. Now please understand, whenever you have a question which is like variable raised to variable on one side, then on the other side you try to keep it as constant raised to the same constant, because when you have something like this directly implies that a is equals to b. Now, here, if you look, you have x upon 3 as your base, and your index is just x. So, what we will do? We will take the third root on both sides of the equal to. So, here your question now changes to x upon 3, the whole raised to x upon 3 is equals to 3 raised to 9 upon 3 becomes just 3. Therefore, now since you can see the bases and the indices are same on both sides of the equal to, here I can say x upon 3 comes out to be just 3. Therefore, I can say value of x is nothing but just 9. Okay. Now, putting your value of 9 in the original question, which was our 3 into x raised to x, is equal to 3 raised to x plus 10. Okay. Now here what will happen over here is, let's put first x ka value 9. So we have 3 into 9 raised to 9. Okay, now 9 can be written as nothing but what, 3 square. This 3 will be remaining as written as it is, and I have 3 square the whole raised to 9. So this then comes out to be 3 into 3 raised to, these indices get multiplied, so we have 18. Now when you have the same base and the indices are different, but what we are doing, the operation is multiplication, then what we can do is you can directly add the indices, which is 1 plus 18, that gets you 19, right? Now similarly over here in your RHS, you have 3 raised to 9 plus 10, that gets you 3 raised to 19. And that is what you got after substituting the value of x as 9 in your LHS. Therefore, I can say x equals to 9 is the perfect solution for this particular question. That's it for today. I will see you in the next video.